Welcome to a video from Bosch Rexroth. Today I would like to show you how to configure an exchange of safe data between two SafeX C15 with SMMC via the secondary Ethernet port of the Control Safety SMMC. Means Safety Master-Master Communication. In this topology example, there is still no connection to a higher level controller via EtherCAT or Profinet. In the video SMMC Part 2 the connection to Profinet is shown. I start Control-X Safety Engineering. The special feature of SMMC is that all SMMC participants must be in one project configuration. How do you achieve this? I take a SafeX C15 and another one. And now I am asked, should I replace it or should it be part of a global network? And that is the case. Now I have two controllers here in a global network, and you can see that here the global network and also this SMMC object are highlighted in red. The background is that each controller gets the same default settings. This means both the IP address and a serial number. This is initialized with 0. Let's change it now to 15 00 00 204. Now the values are already different. The IP address remains at 192.168.1.1. There especially the serial number is important. Here I changed the IP address to 2 at the end, and the serial number is 15 00 00 214. To be able to distinguish the controllers in my project as well, I changed the name and add the serial number. And these two. So, these are the preparations so far. Then I have to set the properties of the SMMC object. I want to show in this video the SMMC communication over the secondary interface, that is the right Ethernet interface. And I reduced the cycle time to 8 milliseconds and 16 milliseconds for the timeout. So, that's the base now. Now I can start with the actual program. I don't need it in this video, but as a preparation for the following video, I prepared the connection to Profinet in the program as well. For a small test program, I'll start with a few inputs. As in the previous videos, it is also here that I have to switch off the cross circuit because I have wired my test setup differently. And then I'll switch to the functional scheme and make a small program here. With 3 inputs here I can increase the number again via the properties. I wire the signals to the N block. Here again is protection against restart, the restart module. And I foresee at least the functional exchange. That is, I get the object and select 5 signals. Which I then send later in the video SMMC Part 2 via Profinet to a Control-X core. The restart required I connect here to the first the result of the logic to the second input. Now I want to wire these 3 signals as well. I could connect them directly, but then I have crossings, and I want to avoid them. So I use terminals ins for that, and then wire those on here. The name is a bit too long for me, so I change it. And now take more terminal ins for the other signals. And change the names as well. The objects are still red. Which means that these created terminals must now still be used so that I can compile the program. This information goes now also to the superordinate control, which we need, however, is said only in the following video. And now I still need a functional input. There I expect then from the superordinate control later that there a restart signal comes through. This is then also done via a terminal in. I call this then restart. And this input of the functional input is the enable input. Now I put a logical 1 on it. And now I have to use this signal. This is now my basic program. Okay. Now I will try to save a little time because I actually need the same program on the other controller. For this I mark the complete program and switch to the second controller. Then I copy it directly into the functional scheme. The emergency stop signals required for this have been created automatically. Now I switch back to the first control. To the functional scheme and open another sheet. And change the name to SMMC. Now we go to the library and see under Global Network that we have got additional objects here. Here we need the object SMMC terminal out. It has a relatively large number of inputs, so I'm going to make it a little larger to be able to use them. Here you can see once again on which controller I am. I am on the first controller, which means that I now take my test signals, with which I can then check whether the signals set here also arrive on the other controller. So now the SMMC terminal in has been added. Then I go to the properties and increase the number. I expect now from the other control, because it is the same program, also 3 inputs. I make this a bit bigger, and here I make my life a bit easier and send the signals to dummy blocks. This terminal and block has properties in which I can select later still SMMC master. I will configure the second master in the same way, and then I have to say from which master I expect signals. The program is finished at this point except for this setting, which I will return to later. I will now go to the second master. Here again into the functional scheme. I make now also a new sheet and supplement the name around SMMC. And now we go back to the library. And here again we take the SMMC terminal out function block. I'll now also wire the signals here that will then be sent to the first controller. So, and then we have here the opposite direction. Here you can see the first master is always selected, but now I also have a second one, the own master. But in this case the default setting fits. Also here now still the dummy blocks wire. Theoretically I can have up to 8 SMMC participants. That means I would have up to 7 blocks and could receive signals from these 7 SMMC participants. What is important is what I said earlier. I must go back now again and here to the first control. And there is now also here a second master available, and I must select this now. So we now have the right master here and I receive the signals from this master. What else do we have here? We still have the possibility to include the SMMC status. I look at the properties. Here I have the possibility to look at the status of the other master as well. First the own status and then the second one. And here I make it easy for myself again and put dummy blocks on it. We can look at that later. Again for control, here the master 0 and here the master 1. So, now it is still important that each of these projects is compiled. Okay. Good. The USB cable is on the first controller, that means I open the device interface. To save now, assign a name. Okay, now I connect and send it into the controller. And close the configuration. Now I have to send the project to the second controller. For this I plugged the USB cable. But to do this I actually have to select the control here as well. Now I connect. And send the configuration and close it. To start the SMMC communication, I need a power cycle once on the controller, that means switch off power once and switch it on again. Do this, I first close this dialog and run it. You can then see from the green LED that the controllers have run up. I reconnect to the controller to check the result. And send the configuration and close it. To start the SMMC communication, I need a power cycle once on the controller, that means switch off power once and switch it on again. Do this, I first close this dialog and run it. You can then see from the green LED that the controllers have run up. I reconnect to the controller to check the result. and activate the diagnosis. When the Get Information message has disappeared the second time, then I can start the diagnosis. I switch to the functional scheme. Here it is important that the function block is active. And now I will first activate the inputs on the controller itself, that is this side. And there you can see the inputs, and as a test now the inputs on the second controller that I'm not connected to. And also here the inputs are coming in. And now we look at the result on the first control and plug the USB cable. And I connect to this control again. And go back to the diagnostics. OK. I'm going to switch to the functional scheme. And here we see that we're getting the 3 signals from the other control as well. These are the own signals here. I have once taken away 2 signals from the controller with which I am now not connected. And now the signals have also disappeared. Here we see the status of the 2 SMMC connections. And this configuration would now also be the basis to let these 2 controllers make a functional exchange under Profinet. But I will show that in a second video. That's what I wanted to show you. Thank you for watching this video. I hope this was helpful for you. If you still have questions, feel free to leave a comment below. Enjoy Control X automation and be 2 steps ahead.